Hi, my name is James Geller, and this is a lecture of about half an hour with a very simplified explanation of what an ontology is. So I'm going to use as an example medicine, so I will talk about the medical ontology the whole time, because ontologies are very popular in medical research. However, you can have an ontology in any subject area that you like. In cars, in fruits, in plants, whatever you like, you can build an ontology for it. But all my examples will be for medicine. So let's start with a problem. Imagine you're a medical doctor. So you need to know the names of lots of diseases. And you need to know the names of many drugs with complicated names. Remember hydroxychloroquine sulfate? When COVID came up, some people thought that this would be a good drug against COVID. And then there are lots of different bones with names and arteries with names and viruses with names and bacteria with names. And all of those are many times very complicated names taken from Latin, long chemical names. So all very difficult. So a poor medical doctor really needs to remember a lot of things. So to help our medical doctor, we want to build a dictionary. But here's a big problem. In the paper dictionary, you can only find the terms when you already know them. Okay, so I said terms. What does terms really mean? So very often a name for a disease or something contains more than one word. And then we don't say word, we say term. So for example, there's a terrible eye disease called macular degeneration. So you see it has two words, so together we call these two words a term. So if you, for example, think of New York, then that's also a term. How do you know it's a term? Because New York isn't really like new car, where you have a car and it's new. You don't have like a York, but it's new. So New York is an example of a term. Okay, so now one more time, in the paper dictionary, terms always appear in alphabetical order, right? So it's A, B, C, D, E, etc. So in the paper dictionary, you can only find terms if you already know them. So for example, over the weekend, I'm doing a crossword puzzle and I'm looking for the name of a certain singer, and I can't find that singer in a dictionary because I don't know what letter his name starts with. So the idea of an ontology then is that we organize our terms, and in my example, our medical terms, not by alphabet, but in some logical way. So, for example, you start by putting all the diseases together, and then you put all the bones together, and then you put all the arteries together, and then you can put all the body parts together. And so body parts includes bones that we have here, and it includes arteries that we have here, and many more kinds of body parts. Similarly, your diseases, you put them all together, but you organize them in some way. Like you put all lung diseases together and all stomach diseases. Or you can organize them in a different way. You put all diseases that are caused by a virus together and all diseases that are caused by bacteria, put them together. And bones you can organize by location. You put all the bones in the head together and all the bones in the leg together, for example. So you end up with some organization like this. So You have body parts, and among those are bones and arteries and organs. And among the organs are stomach and kidney and heart. And then you do the same thing for drugs. You do the same thing for diseases. You do the same thing for bacteria. Same thing for viruses. Same kind of collection organization for medical tests, like blood tests. Same kind of organization for surgeries, like where is the surgery located, what body part, for example, or what kind of tool are you using? Are you using a knife or a laser? So you organize all those dictionary words in some logical manner. Now let's say you're the doctor, and the doctor had to learn so many terms that he can't remember everything. Or maybe it's not a doctor, maybe it's just a medical student, or maybe it's you who has a stomach ache and you want to find out all diseases of the stomach. So, but let's say that your doctor has a specific stomach disease in mind, but he just can't remember the name of it. So, the two things that we know, it's a disease and it's in the stomach. So we need some kind of connections between the diseases and the body parts. So before I said, organize the diseases separately, organize the body parts separately, but now we need some kind of connections between diseases and body parts. So when you search for the specific stomach disease that you forgot, when you start searching at stomach and you follow links to diseases. So visually, you can think of it this way. So you start at stomach, and then you follow a link to stomach cancer, a link to ulcer, a link to reflux disease, for example. Okay, now I use the word links a lot on the last page. So these connections are called links, and they represent relationships. So a simple relationship that is really important in medicine is in, because the COVID disease happens mostly in the lungs. Of course, in real life, we have many different important relationships. The most important one is probably part. And then we have relationships like attached to. So the door handle is attached to the door. And we have relationships like owns. So I own my car. And then there is the need for connections from diseases to drugs. So let's say now you've determined that the disease is pneumonia. Pneumonia. Am I not missing an I here? Pneumonia. Yes, I missed an I here. Sorry. So pneumonia is a lung disease. By the way, in 1997, I had it. And you want to know what drugs exist for pneumonia. And let's say, for example, again, you can't remember the name, or you're learning the name, or you're not an expert, you just want to see what's available. So once again, we know two things. It's a drug, and it is used to treat the lung. So in that case, we now need, again, cross connections. Let's make this red again, between diseases and drugs. So we start at pneumonia and follow links to different drugs. So pneumonia can be treated with penicillin. It can be treated with erythromycin, which I was treated with. So I like that drug a lot. It saved my life. And it can maybe be treated with tetracycline. Now, all this is becoming very complicated. I promised you a simple introduction, a simple explanation, but you see it's already very complicated. So over many years that people worked on this, it turned out that it's easier to understand ontologies if you represent them with a drawing, as long as the drawing is small. So what you see over here, that already is like the start of a drawing. And now here we have a drawing, and these boxes with rounded corners represent terms, and the links, which we also called relationships, are represented with arrows. So an ontology is a network of terms connected by relationships. And here is a mini picture of terms and the arrows in between relationships. And before I said part of is the most important relationship, but actually the most important and sort of privileged relationship in ontology is called is-a. So much so that we're distinguishing between is-a and everything else. So is-a relationships connect terms to more general terms. And semantic relationships are these cross connections that I was talking about, and I color-coded this. So the is-a are in black and the semantic relationships are in red. So I'm going to spend a lot of time on this diagram, but this is a mini ontology, and it says that the malignant intestinal neoplasm, whatever that is a malignant digestive system neoplasm, whatever that is, which means that this thing down here is more specialized, and this thing here in the middle is more generalized, and this thing up here is even much more generalized. Furthermore, this tells me that a malignant intestinal neoplasm happens in the intestine. So now instead of just saying in, we're calling this associated anatomic site. Now, just that you know what we're talking about, and trust me, you don't want to know it, a malignant digestive system neoplasm is really a cancer. So a malignant neoplasm is a cancer. And the digestive system, that's really stomach, liver, and gut, and a couple of other organs. And the gut really consists of small intestine and large intestine. And the small intestine has 3 different parts. So all this together is called the digestive system, and the intestine is a digestive system, which sounds a little strange, but it's correct enough to use it. Okay, so a malignant intestinal neoplasm, the bubble down here, is really a cancer of the gut, because the intestine is the gut. So the nice thing about an ontology diagram is that you can literally read it like a sentence. So look at the 3 things that are in this green ellipse over here. Malignant intestinal neoplasm is a malignant digestive system neoplasm. So you can literally read it that way. And as I already told you, that the bottom one means cancer of the gut, then you can just read this. A cancer of the gut is a special case of a cancer of a digestive system. Now, one thing that's very important in computer science, you're going to learn about trees, and unfortunately, ontologies are too complicated to be trees. So over here, you see a node that has 2 different parents, which is prohibited in a tree. So bacterial pneumonia is 2 different things. It's a lung disease because pneumonia happens in the lung, and it's also an infectious disease because it's an infection with bacteria. Now, you know from COVID that it's a viral disease, that also happens in the lung. So in this case here, we use family terms in ontologies. So we call bacterial pneumonia of a child, and lung disease is one parent, and infectious disease is another parent. And in an ontology, the different terms can have two parents or sometimes many. Okay, so we've already seen that ontologies can be displayed with diagrams that consist of boxes and arrows. But the thing is that this becomes overwhelming, and there are more than about roughly 20 to 30 boxes. So this was nice and simple, but when we get to something bigger, it will not be so nice and simple. And real biomedical ontologies, the ones that doctors are using, sometimes contain hundreds of thousands of boxes and arrows. So just to give you the message in a visual way, what you see here is a piece of an ontology called the National Cancer Institute Thesaurus. And this one consists of only 8,445 different medical terms and 40,420 relationships, arrows, links, remember, more or less all the same. So when you look over here, these tiny dots, there's a tiny dot up here at top, and these white dots that you see, every one of those dots is really one of those boxes here. So you see, this is obviously very overwhelming, and without giving you too much reasons and explanations, it doesn't help to zoom in. It still stays overwhelmingly complicated. For example, because some of these concepts have very many children. Imagine you just started a disease and there are thousands of diseases. So it's not true, but imagine that up here, this note here is the term disease, and then there are thousands of things under it. So zooming in doesn't really help. Okay, so our big idea is to use three-dimensional diagrams, and furthermore, we are not limiting to a small computer screen, but our idea is to literally walk through those diagrams in a virtual reality environment, and for that you wear these special virtual reality goggles that make it look like you're really standing inside of a space, and a three-dimensional space like the real world. And if you have never experienced this, you will, and it's actually a very, very exciting feeling that you can walk. I've literally walked through the streets of Rome standing in the lab in Newark in NJIT. Okay, now, as I said, this was all a very simplified explanation. In fact, it's much more complicated. You don't really need to know that, but I want to mention it at least briefly. So first of all, I kept saying that every one of these boxes represents a term, and it's a term because very often it consists of more than one word. But the fact is that ontologies really are built of concepts. So you might wonder, so what's the difference between a concept and a term? And the answer is you can describe the same concept by several terms. So for example, heart attack is the same concept as myocardial infarction. The red word and the blue word mean the same thing. So then the concept of heart attack can be expressed, not surprisingly, by heart attack, but it can also be expressed by myocardial infarction. And so the boxes in the diagrams are also called nodes, and the arrows are called links. That term, the links I've already used the last 15 minutes. Many people prefer to use the word classes instead of concepts. Not going to explain this any further. And when two terms mean the same thing, so like heart attack and myocardial infarction, then they're synonyms of each other. So to briefly get out of medicine, a computer screen is a synonym of a computer monitor. Okay, and here is a brief summary. So an ontology organizes the words, terms, concepts of a subject area. An ontology diagram shows the ontology. The boxes / nodes represent terms / concepts. The arrows / links represent relationships. And it's easier to find terms, concepts in an ontology than in a dictionary, because you can find them based on the organization, as opposed to a dictionary where you just have a long list of terms in alphabetical order. Once again, my name is James Geller. My email is james.geller@ngit.edu. And if you have any questions for me, please do send me email. Thank you for your attention.